this video, I will be explaining how to obtain the derivative of some very known functions using the definition of derivative. The first function that I'm going to use is the constant function. So assume that c is a constant, whatever real number, and the image of every element is that c. If that is the case, find the derivatives of f. And I'm going to use the definition of derivative. So to get the solution, we use the fact that the derivative of a function always is the limit of h approach to 0 of f of x plus h minus f of x over h. In some textbooks, instead of h, they use delta x. So we know that first we need to compute the image of x plus h, because the function is f of x equals c. Then I can compute, for example, the image of 3. The image of 3 is going to be c, if we have this function. Or the image of t, it will be c. Or whatever, the image of a plus b will be c. So the function is telling me that the image of every element, it will be c. So the image of x plus h will be c. And here they say f of x is going to be c also. So when I go and compute this ratio here, f of x plus a minus f of x over h, so the only that I need to do is just make a substitution. The image of x plus h is c, so I'm going to type c, minus the image of x, the image of x is c, so it will be minus c. Everything divided by h. And I know that c minus c is 0, so it will be 0 over h, and this is 0 or whatever number if h is different than 0, so that will be 0. And I know that h will be different than 0 because this is the limit at h approach to 0. So it's not taking the value 0, it's just taking whatever value close to 0. So it will be 0 over that value, so that will be equal 0. So we have that when h take values closer to 0, the value of this ratio will be 0. So when I say limit of h approach to 0 of f of x plus h minus f of x over h is the limit at h approach to 0 of 0, because all this ratio is 0. And the limit of a constant is the same constant. Yeah? So we have that this is 0. And then we have proof that if we have the constant function, so the derivative will be always 0. Or whatever constant function. If this is f of x equal 8, whatever number it did see, the derivative will be 0. So for example, if I ask you what is the derivative of 8, using this notation, yes, this is a Leibniz notation, so the answer will be 0. The derivative of minus 5, that will be 0. Another very known function is the identity functions. So the identity function is defined in this way: f of x equal x. So the image of every element is itself. So the image of 7 is 7, the image of 8 is 8, etc. And we want to find the derivative of this function. What to do? So I'm going to use the definition. And we know that if the function have derivative, the definition of this derivative will be the limit at h approach to 0 of f of x plus h minus f of x over h. And remember that this h is the variable and can have other names in other textbooks. So what we are going to do is just substitute what is the image of x plus h, what is the image under this function f of whatever number x, and just substitute here. So I know that the image of x plus h will be x plus 8, because the definition tells me what to do to get the image of whatever function. If I want to compute the image of 3, that will be 3. Or the image of t, that will be t. Of the image of a plus b, that will be a plus b. then the image of x plus h will be x plus h. So the image of the element is the same element. So this ratio here will be given by the image of x plus h. We notice here that is x plus h. The image of x, we notice here that is x, so it will be minus x. Everything divided by h. And we notice that this x cancel with this x. So actually what we have is h over h and h over h. If h is not 0, and this is the case, h is not 0, because this is the limit as h approaches to 0. So taking value closer and closer to 0 without being 0. So whatever value different than 0, the answer here will be 1. So computing the limit of this ratio of x approaches to 0 is actually computing the limit of 1. So what we have is that the derivative of the function f in this case will be that limit, but this limit will be the limit at h approaches to 0 of number 1. And we know that the limit of a constant is the same constant, so it will be 1. And for that reason, we say that the derivative of the identity function is 1. So we can write that if y equal x, for example, the derivative of y will be 1. Or if I ask you, what is the derivative of x respect to x? Oh, that will be 1. Another function that people use a lot is f of x equal x squared. What is the derivative of this? Most people know, yeah, but how to obtain this derivative? If f of x equal x squared, so we have to find the derivative using the definition is just remembering that the definition is always this, and we need to compute obviously the image of x plus h, and we know the image of whatever element, yeah? So whatever element, the image will be the element square. So in this case will be x plus h squared. This is a binomial square. This will be x squared plus 2xh plus h squared. We know what is then the image of x plus h under the function f. The image of x we write here in the definition of the function, that is x squared. So here this second term at the numerator is just x squared. So I can type then that f of x plus h minus f of x over h will be equal to the first term will be x squared plus 2xh plus h squared. That is this first term at the numerator minus f of x, that we know by the definition of the function, that is x squared. So minus x squared, everything divided by h. And we notice here that x squared cancel with this minus x squared. So what we have is this 2xh plus h squared over h. But we notice here that h is a common factor. So we can get a common factor here, and this will be h, common factor of 2x plus h, yeah? So it will be h that multiplied to x plus h, and divide by h. So everything divided by h. And again here, if h approaches to 0, taking values closer to zeros, there are no 0, so actually we can cancel this h. And then what we have is the value is 2x plus h. So the limit as h approaches to 0 of f of x plus a minus f of x over h will be equal to the limit at h approaches to 0 of 2x plus h. That is the value of this ratio. And this is a limit that you can obtain easily just making a substitution h by 0. So the answer here will be 2x. And that is, so the limit of x squared equal to x. So we can type that the limit of x squared will be equal to x. And this is something that can be generalized. You see this exponent is written here as a coefficient. The exponent here was 2, now is 1. We have subtracted 1 to the exponent. So this is something that can be generalized in this way. if we have the derivative respect to x of x to the power n, so that will be equal to n multiplied by x to the power n minus 1. And this can be proved in a similar way that we did here, using in this case the Newton binomial. Here was the Newton binomial to the power 2. So if we use the Newton binomial to the power n, we are going to do something similar and we are going to obtain this. This is what people call the power rule of the derivative. We can use what we have obtained so far and include some other rules to make a list of rules of derivative. In this list, k and n, when you see the k and n, they are going to be constant. ux and vx will be functions, and this function has derivative. The first rule is one that we have already seen, is that the derivative of a constant will be 0. So this is the first rule. We call it the constant rule. The second rule is that the derivative of a power of x, so a power of the variable respect to which we are going to compute the derivative respect to x, and this is the variable I have here, x to the power n. This is n multiplied by x to the power n minus 1. So this n is written as a coefficient, and also we type an exponent that is the previous one reduced by 1. So this is what we call the power rule. It's not necessary to type the identity rule, that the derivative of x equal 1, because the derivative of x is actually x to the power 1. And x to the power 1 will be 1 multiplied by x to the power 0. So it will be actually 1 multiplied by 1, and this will be 1. So the other rule that we have already seen is written here. But we have other rules. I'm going to be making videos in which I'm going to prove these rules. But let's type the rule here without any proof. For example, if we have the derivative of a constant multiplied by a function. So that will be the constant multiplying the derivative of a function. If we know how to compute the derivative of this function, we are going to know how to compute the derivative of the function multiplied by a constant. For example, now that I know, using this rule, that the derivative of x squared equals 2x, I also going to know how to get the derivative of 7x squared, because it will be 7 multiplied by the derivative of x squared. This is what we call the constant times a function rule. And if we have a sum of two functions, or the difference of the two functions, so what we're going to get is the derivative of the first plus the derivative of the second. So it will be here the derivative of ux. If we have a plus, it will be plus. If we have a minus, we're going to be typing a minus, the derivative of the second function. So the derivative of ux plus vx will be the derivative of ux plus the derivative of vx. Notice that we know how to compute the derivative of x squared using this rule. And we also know how to compute the derivative of x3. So we can also know how to compute the derivative of x squared plus x3. So now we know how to compute the derivative of a sum and also the derivative of a difference. We call this just the sum and difference rule. The fifth rule here will be the derivative of a product. We can do it in this way, the derivative of the first multiplied by the second function, or the second function multiplied by the derivative of the first function. And then plus, always plus, the first function multiplied by the derivative of the second function. So, and again here, because this is a sum, this is a commutative operation, so you can type this first. You can type this expression first. So this expression, this product here, and this sum can be in a different order. So there will be no problem. And you can find textbook that give this rule in a different order. But anyway, what you need to do is get one of the function, multiply by the derivative of the other function. And then plus the function that you have already taken the derivative. Now you are going to type it without taking the derivative and get the derivative of the function that was not derivative in the first term. So that will be two terms, and in each term will be a derivative and a function without derivative. And with this rule is called the product rule. And for if we have a quotient, so we have another rule. Yeah? If we have the derivative of a function over another function, so it will be something similar you are going to get, but now the order will be important. First, you need to get the second function without derivative. So I'm going to do it the way I did it here. Vx multiplied by the derivative of the first one. Minus, now that is the reason why the order is important. So now it's important that the first function that you don't get derivative will be the second one and get the derivative of the first. Minus the first one that you already took the derivative multiplied by the derivative of the second one. The reason I type the fifth rule in this way is because I want that you remember this order. It's the same order that we are going to be using, that it will be mandatory, by the way, in this sixth rule. So because we have a subtraction, and the subtraction is not a commutative operation, so you will need to do it in this way. So it will be as a second term the first function multiplied by the derivative of the second, and everything divided by the second, but now a square. So you are going to use the same function that is in the denominator and raise it to the power 2. So this S6, this derivative, S6 for each value of x when the Vx is different than 0. So this derivative S6 for all value of x where the denominator is different than 0. And we call this the quotient rule. So there we'll have rules for special functions also. For example, you have the derivative of the exponential function. The exponential function, the derivative of the exponential function is itself. So the derivative of ex, e to the power x, is e to the power x. The exponents need to be the same variable respect to which you are going to compute the derivative. So this is respect to the variable x, and e is to the power x. So then the value of the derivative will be e to the power x. This is the exponential rule, and we have a rule for the logarithmic function. If you have the derivative of natural logarithm of x, it will be 1 over x. And again, that is 6 when x is different than 0. So this is the natural logarithm rule. To end this video, I'm going to speak about another rule, the chain rule. And the chain rule, we call it here the rule number 9, is for composite functions. So you have not just a function respect to a variable x. So you have a function, let's see, respect to a variable u. And this u is another function respect to the variable x. And we are going to get the derivative respect to x of this y. So for example, if you see here e, instead of e you type e to the power x to the power 2. So this x is to the power 2. In this case, e is not to the power x, will be e to the power a function of x, that I call here u. So a function like this is called a composite function. If we have a composite function, so to get the derivative, what we are going to do, I am going to show you some examples in videos. It will be that the derivative of this y will be the derivative of this function f respect to u multiplied, so the derivative of y respect to u multiplied by the derivative of u respect to x. So the derivative, because this u is actually a function, so we call multiply by the derivative of this u respect to x. And when I write here y prime, I'm speaking about the derivative respect to x. So the derivative respect to x will be the derivative of y respect to u multiplied by the derivative of u respect to x. Notice if these were actually two quotients multiplying, so this du and this u cancel, and the answer will be dy over dx. So that is actually y prime. We are going to be using this also for solving some derivative, but that will be in some other videos. Here I'm going to stop the explanation for now.